Okay, so the assignment is in some ways similar to previous years. It's still different, but the idea of it is similar. It's a booking system. So what's going to happen is you're going to be booking skydiving lessons or skydiving jumps. I don't really know the terminology. Um, and there's three kinds of jumps that you can book, as you can see here. So there's like a training, which is basically where you jump with someone to practice your technique. There's a fun jump, which is just where you kind of jump by yourself or with some friends. And then there's a tandem jump, which is where you're kind of like attached to someone and you both go down together. Um, and so again, this is very early spec, so don't take anything in here as absolute. A lot of it will change. Obviously, I'm not going to click on the solution. Okay, and we'll just go through that. So there's a few things here that we'll notice immediately. And the first thing that we notice is that there's a relationship between the classifications, right? And so it here says, for example, that tandem masters, which are the people who you hold on to, right? So basically they kind of carry you down and they kind of skydive by themselves and they kind of just get you used to like the feeling of it. They are instructors, right? And thus they can fulfill the duties of an instructor. And then you also have the fact that all tandem masters and instructors are sport jumpers, right? And can act as such, right? And you also find that all three of these are also students, right? And so you kind of have this inheritance tree, right? Of tandem masters being at like the very, very top and then distributing outwards or downwards rather. And so like the next level would be instructors, then sport jumpers, and then students. And with jumps, they're all very different. So jumps don't really have any relationship between them, but they would have like a unique base class. But there are differences between the two, and the interesting things is it's all based on hiring gear and repacking gear, right? And sometimes it's conditional, right, as you can see here, but very often it's specifically based on the class. Except for this case here, right, where it's unless. And so this having gear or hiring gear and the need to repack it or not is actually important because it affects timing. So the whole point of what you're doing here is you're basically trying to choose um, jump runs, right? So you're trying to choose the order in which people will jump from the plane, right? And you're trying to do it to maximize the horizontal safety between the groups. So basically, you're trying to do it so people are spread out as much as possible, so people don't like skydive into people, which is obviously not a good idea. Um, and so in this case, right, the timings that it takes for them to repack gear affects how fast they can go into the other jump, right? So if you don't have to repack your gear, you can just immediately go into another jump. Whereas if you do have to repack, then you have to wait those 10 minutes. And so that affects the timing in terms of when people can go into the next jump and what planes they can get and so on. And so effectively, your system will receive a bunch of commands that indicate system states. So for example, here's a new skydiver, with a license. Here's a new airplane flight that's going to go at this time, ending at this time, carrying this many passengers, that's going to drop at this specific position. And then you have all this other stuff here, right? And so all of these, there's to cancel, there's to change, and then this is your final generate. And so these like build up the state of your system, and your generate kind of brings all that state together and kind of gives you a final output. And there's a bunch of the spec is really large, as you can see, right? And so I mean, this is actually from the old spec. There's nothing to do with venues, and so when you're doing stuff like this, the recommendation is to like sit down and try to like graph it out. And maybe I'll draw a diagram or something to kind of show you the relationship between it, because it is kind of complicated, because it's like there's a decision tree, as you can see here. So all the jump requests, when we want to choose, who goes in which flight effectively, we grab every flight from earliest to latest on the chosen day, right? And then we determine whether or not it can allow all the participating skydivers who want to go on that flight, and provide appropriate trainers, right? And the people you like hold on to as you go down, which is called tandem masters. And so the thing is, we have to choose the best flight at each point such that we can get the most people on it. Um, and then it's also based on the number of drop zones, right? Because obviously if you have two different flights which are dropping at different positions, they're not going to clash, right? They can just go, even if they're the same time. Whereas if they're going at the same drop zone, then they're effectively going to be the same flight if they're going to drop at the same time. And there's a bunch of other stuff here, right? So just try to the recommendation for this assignment is feel free to email me questions about it. It's kind of hard because you guys haven't read it, so it's kind of hard for you to know what questions you want to ask. But the rough kind of way that you're going to be sending this out is start off by defining your classes and don't write any code really. So you're going to define classes for your jump types, for your skydivers, and you're going to define as many classes as you want. And in relation to that, you're actually going to be designing a UML, right? As you can see here. And the UML, there's going to be a bit more specification about the UML, like what you have to include in it. That's just not there right now. It'll be there by tomorrow. And so recommendation is to start with the UML, or to at least start with the classes in your code, and then you can build the UML. Again, don't auto-generate it, just make it by hand. You will lose marks if you auto-generate it. And so the point here is that as long as you kind of got your class layout okay, you'll get most of the marks without having to worry too much, because quite a few of the marks, as we can see down here, is design and style. So more than half the marks is nothing to do with how accurate your solution is, but entirely to do with how appropriate your solution is, if that makes sense, right? And so design, holds the UML diagrams, it holds your JSON test files, so you got to write extra test files to test your program. Typically, those are only worth 1 or 2 marks. And then a big part of it is this adherence to OO design, right? And that basically means that are you actually using classes appropriately? Or do you just have all your logic in one big class, which sometimes people do, right? So basically, make sure you're adhering to LOD, law of Demeter. Don't just suddenly for example, let's say you want to try to book something, don't go inside every and then ask it for all of its drop zones, and then from there ask it for all the skydivers. Try to move the logic that decides when things get picked into the classes that manage those resources. Right? Don't just continuously drill deeper into the object to find the data you're looking for. Try to abstract that away. Effectively your main code should do very little. So I can't show you the function because it'll have the actual solution there. But the actual main version that kind of takes all your input in and decides which of these commands to run should be just decide which command to run and then immediately call a function, right? And that function should be probably within a class. It really doesn't have to do that much, right? Some of them are a bit different. For example, Quest, I may have to go and ask all the planes that are going to whether or not they can fit a time in for the skydiver. Or for example, when you got to cancel something, obviously you got to go find what thing to cancel. Right? You'll have to do a bit more than just core functions inside a class, right? But you don't really want to pull a bunch of information outside of classes. I mean, there's a bunch of other stuff here that you'll probably want to do as well, right? And you'll find that as you go, right? So you go, okay, for example, I talked about this being inheritance, so you got to think about the inheritance order, but also other things to do with it. And I mean, this is a very nested example. So for example, tandem master nests on top of instructor, which nests on top of sport jumper, which nests on top of student. And that kind of sucks. Typically, we want to try to avoid a huge amount of nesting, right? Where there's a huge, right, every class is nested to the next one because it makes the code more complicated. But in this case, there's other ways you can solve this problem rather than just necessarily giving them all the same class, right? So think about what makes them unique and so on, and try to decide whether or not you always need a class, and maybe you do, and that's a fine solution, or maybe you can do other ways, right? But you shouldn't just end up with a bunch of switch cases, a bunch of if statements to do class logic, right? If you got to have if statements to check, oh, okay, if my type equals instructor, do this. If my type equals tandem master, do this. Then that behavior should sit inside a class, right? So, for example, a common behavior that we see is stuff like this, right? Where let's say we have some kind of room class or enum rather. and this enum contains a bunch of options. Enum is just like a bunch of hash defines, right? So these are just a bunch of options after each other. Each have integer values. So for example, maybe our first option is small, then medium, then large, right? And so what we end up with is people do things like this where they switch the room type and they go, oh, hey, if it's a small room, do this logic, right? I think it's gonna be like this. If it's a large room, then do this and so on. And so they basically break it down into a series of steps, or they write if statements like this, right? Um, and the problem with this is that this behavior, it's not necessarily that it's not necessarily to say it's bad. It's just to say that you're basically grabbing a bunch of behavior and you're pulling it outside of the class that's responsible for it, right? And so instead you can put this behavior inside this room type class, or rather you should put it inside even the room class is okay, right? It doesn't always have to be inside the class that actually specifically holds this variable, right? It just has to be inside some class that makes sense, right? So a room class would make sense here. Room type would make sense, maybe even a different class, right? And so you shouldn't just be adding classes in every way you can, right? It should be deliberate. Anyway, okay, this is basically it, and you can look at this, all the various different groups. In the order which they exit. And there's a bunch of other stuff here that we talked about. For example, what you need to do in implementation. You're going to be using a JSON library, but most of the JSON code will probably be written for you. Very little you'll have to write yourself. And it's not to write, luckily. So you'll be fine. People typically find the JSON code the easiest part of the assignment every year. Uh, The only other thing is that no human marking will be applied for the auto marking. So if there's no partial marks, right? So what that means is this is not something that necessarily is fantastic. I'm sure although you worry about that. And so for that reason, typically in last year's the not exam questions, like the marking questions are typically easier. So there's not a lot of like edge cases. So as long as you write some decent tests, they're typically fine. There are, but you get very few. You only get like one or two. So you have to write some more. And more importantly, you have to write some more that are extensive. But typically, the ones we run on aren't very edge casey. Yeah, that's it. As long as I really want to talk about, and you create a PDF. Where you want to create UML diagrams, draw.io works perfectly fine. Like I can load a UML here. I don't know what one this is. We'll just see, I guess, when we load it. And you also give at least 3 JSON files. I recommend that typically, if we look at like the mark distribution, people of how many tests they write, unless they write like silly tests, which a few people do, you probably look at like the average mark distribution is probably plus or minus 1 mark, right? Dependent upon how many tests you do. So if you do 1 test, you probably get like an average, an extra mark. If you do 2 tests, you get an average about 2 marks. And if you do 3 good tests, you get an average about an extra 3 marks. Typically on average, if you look at it. And so people who do 0 tests typically get somewhere between 3 to 4 marks on average out of the 7. So you may beat the average, but typically, I mean, on average, people do not. So anyway, so this is a UML. We'll talk about UMLs later on. This was the one for my project. They get very large. This is probably not even that big compared to a lot of other people's. This will not be something the size that you'll be writing for this. Your one for this will be smaller. This will be like your final project, right? Your final project may be this big, probably be a bit smaller. And so obviously there's a bunch of things at UML. There's I think a lecture on it. If there's a lecture yet, there will be one soon. I've also made a video. I don't know if I'll go for it today, but I'll at least release the video. I made it like last year, so I think there's a bit of keyboard noise, but I don't really type, so that's fine. In the video list. yeah, anyway, and so it goes through, and people said it's a pretty good video, so we'll see how that goes. Let's just get straight into it. So what we're going to do is look at the actual week, and we're going to begin with the Kahoot. And then we're going to see how well people know some of the stuff that we've been going through. It's very loud. Jeez. Okay, so the pin's there. Try to join. See how this goes. I made the Kahoot different. Some classes have done Kahoots. I don't really always love them because I feel they don't give enough material. But I try to make this one a decent balance. I'll put the link in the chat. Okay, there you go. So try to join, and the game pin is up here, which I'll also copy. I've started when a few people have popped in. Love the African emojis. I wonder who. I wonder who is this? Oh no, they left. Why did they? Oh, did I drop you out? I'm sorry, Shayla. I didn't realize that happened. Can you join back in? I'm sorry. Is that you? Uh, oh, good. Okay. I think we'll start in a second. I don't necessarily have to wait for everyone. I'll probably wait for about 12 people because I don't know how many people are listening. Actually, again. uh, question. I wish I could like make the audio play through. Sadly, you can't share audio through BB Collaborate because the music is an absolute vibe. Anyway, I think I'll start in a second, unless anyone else wants to get in. I think you can still, yeah. So you can still join us as long as you've got the code. So the code's in the chat. So you can just use that. Okay. So it's basically just a question asking whether or not the code compiles. You have about 20 seconds, which is quite significant. So these are three separate packages and three separate files, right? So keep that in mind. These are three separate files. I can't really show three separate files. Was that too slow? Let me, did people find that too fast, rather? It's hard to see the code. Okay. Well, it's hard to scale up. Okay, how about okay, for this question, because I think this question is important, I'll share the code like that, and I'll create a poll in the chat. Yeah. So, well, okay. So one person said yes, right? And I just kind of want to do a poll in terms of what question you think you would have answered. Obviously, you can see the answer here, right? But I just kind of want to understand. So it's yes. Does this compile? Um, modifier. And then there's also um, okay. So those are the questions. So just try to like answer as if you would. Because I just want to understand like where people are at with this, so how far I have to explain each question, right? That's really what it's for. right? And so there's two things that come from about this, right? So the first thing is that we have this first file here, which is package A, which has foo, and this returns 42. And this is protected, which means it could only be used in subclasses and the same package. And then we have package B here. Now, package B includes bar, which also returns 42. But this is an override method. This overrides this method here. But the reason why this override method is allowed is because it's effectively weaker, right? There's less strict access, right, to answer, which means more things can access it. And this is important because it means it obeys Livskov's substitution principle, right? Which means that every bar can become a foo. And the reason why, because every bar is at least protected. It turns out that it's more, right? There's more access, but it's at least protected. However, if we made this private, it would not compile. And the reason why is because if this was private, it would have less access than its parent, which means I can't just convert a bar to a foo. Because there's some cases where this wouldn't be callable outside the function. Right? And then the final instance here, which is with this meow, the reason why we can answer this, even though this is inside a different package and this is protected, right, is because we're accessing bar, which means we're accessing this public method here. If we said, if this was foo, right here, if this was foo, then this would not compile. And the reason why is because if this was foo, we'd be trying to access this method here, which is protected. Right? We can't access the protected method outside the package. There you go, surprise face. What do we want and when do we want it? Most of the questions from this on or here on out don't actually have that many images anymore. I'll make the images larger for the sake of it. If I do this in the future, I'm going to make it slower because I think it's too fast. Okay. So the answer is, as they said, low coupling and high cohesion, right? You want your modules to be very lowly coupled, so they're not combined together, so they're not reliant on each other, because that means code becomes harder to update, because then you have to update more places. And high cohesion just means they work well together, right? There's none of these like awkward edges or anything like that. Yeah, you had a lucky start, but doesn't look like it's going to last for too long. So we have output of the following, which I will. Okay, I cannot make that. I thought I could make that bigger, but that makes it worse. I can do this. I don't know. Is that at least visible? Okay. I'm going to make the images easier to see in the future. But this was the thing. I can't show it where I'm going. So let me just pull up the actual images so I can show the one. Okay. I'm just going to pull up the images on my side so I can just pull them across for you so we can actually look at them in a bit better detail. I just have to find where they are. On my desktop somewhere, but that does not make it easy. Which the following is override, which is bad code. Okay. Can I make this bigger? What were the options again? I'll list them again and see. So the options were quack, quack, moo, moo, quack. And then this one here, which was, let me see if I can come up on the spot. So it was moo. No, it'd be quack, followed by quack again, followed by moo, followed by quack. So this one would be quack, quack, moo, quack, and then this one because it's the right answer, and then I think the other ones. Let me get them up for you. Okay, you know what? I've got an idea. I'll open this up, then I'll just put them side by side. Big growing pains. Let's get used to this. Okay, you can see them side by side. Just some sanity. Right, and so the answer here was quack quack, and the reason why is because this function call here is going to create this new class, and so when we say c.speak, we're going to quack, right? And then when we go to the next function call, which is this one here, right? We're not actually creating B, we're just allocating C to B, right? And so what's happening here, and people say quack, 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 quack. I thought no one would guess this one. That's fair. And so when we have B.speak here, right? What we're basically doing is we're saying, okay, call this method, right? But this overrides this method. And since this overrides this method, we're actually going to end up just calling this because we're using C, right? So it's not based on the type here. It's based on the initial type. Yeah, no worries. That's more my fault than you. I'll make sure when I do this in future that I make the images separate rather than doing it within the thing. Because I think doing it within the thing makes it too hard to make them visible. And then we have B, who's new B, which is basically just going to allocate mu here, speak mu, and then we go back to C, which is going to be the same first one, right? Okay, we can toss that one away. So the answer is quack, quack, mu, quack. Ooh, that's actually kind of close. What's the next one? Okay, so the next one is going to be another image one. So let me just save that image. That way I can put it up side by side. So the question here is we have these two classes and it's awkward because for some reason it's decided to add these extra bars on top. Why? Oh, here we go. This is what I want. Save as. Nope. Anyway, and so you can see the question here. Hopefully this is readable, right? This says foo. If this doesn't make sense, right? So this says foo, and then we have A, and we got B. This is static. This is normal, and then we have B down here, which is got A, B, and C. Sorry, A, B, B, and then there's this one here, which has a C argument, right? Which is an integer. So the question is denoting which of the following is a valid override. So we're saying, hey, is this a valid override? Does this compile? Does this override this static function here? Does this one override successfully this? Does this one successfully override this? And the correct answer is none, right? Now, this is good because this is a tricky one, right? So let me put them up side by side and try to look at this in a bit more detail, right? So the first thing is that most people guessed blue, right? And so blue was probably like the second option that it's still wrong, but it's like the second best option, if that makes sense. So A is wrong because you can't override static functions, right? That's just like straight up. Static functions belong to the type; they don't belong to the instance, right? So a whole point of an override is that the you're overriding the instance method, right? So even though the type is different, right, it's still using the original instance method. So that kind of the instance method carries along regardless of what type it currently is. Just like we had in the previous example, right? I can't get it back up, where we kind of casted you know, B back to A, and then we found that it would still print quack, right? Even though we casted it back to the original type because it was an override method, which means it maintains the methods that the original type had, right? Whereas static functions always belong to the type itself, and so you can't override this because since this type is this, right? It's always very obvious which method we're calling. If I say foo.a, it's very obvious I'm calling foo. There's no way I could ever call bar because it belongs to the type, right? The next one was C, which was this method here. This method here is also kind of in some ways correct. The reason why this is wrong is because there's no base method in foo that has an argument called C, right? And so we're not overriding anything by doing this, right? Because there's nothing here that looks like that. Right? Like the arguments have to match, but everything else is okay. And then this one here, which is kind of, as I said, the second best, it is just the problem is that we're going from public to private, right? So this is more restrictive. So what this means is that if I cast a bar to a foo, I'll be able to call the B method, whereas I couldn't originally. And that's problematic, right? And so basically you're breaking encapsulation. But more importantly, it means that it's not necessarily obeying Livskov's principle, which means that every bar is not necessarily a foo, because for every bar to be a foo, B has to be available at least publicly, which it isn't in this case. Okay. What's the next question? Just check whether or not it's going to be. Yeah, so the next question is going to be interesting. We're just going to save this image. I'm actually just going to rewrite it back out because it will only take me 10 seconds to write this one. This one was just this. A little bit more than 10 seconds. Okay, fair enough. Okay, and then we're just doing get nth car. Next week, I'll make the images larger or do it to the side by side. Otherwise, it's too annoying. But this week, we'll just do it this way. There's a bunch of code here that looks very confusing, right? And the whole point is you don't have to understand how any of this code works, right? You just have to figure out what's wrong with it, right? And in terms of design. So the idea is that what's actually going on here isn't really that important. So let me just go to the next question and then I'll pop it back up. Ooh, hello. And let me just move over here. So the question is, what is wrong with this design-wise? And I mean, this isn't really that important, this new thing, but there is. So is it breaking encapsulation, breaking law of Demeter, breaking Malice's law? And there's nothing wrong with it. Let's see what people got. So people say it's breaking encapsulation. A few people said breaking Malice's law. This isn't a real law. I mean, it is. It's a physics thing. It's not anything to do with computer science. Again, I'm sorry for them being too fast. You just can't change it when you're going through it. And I don't really want to go through all the questions again. In the future, I'll make it like a minute rather than like 20 seconds, which is just too slow. Too fast rather. So Malice's law, it's something that relates polarization, which is kind of like light has kind of a direction, if that makes sense, and like the polarization is effectively that direction, and so it's saying that relates that angle to the intensity of the light. Anyway, and then we have here breaking law of Demeter, which is actually a computer science term, and encapsulation. The reason why it's not breaking encapsulation is because encapsulation is all about hiding things, right? And this hides things perfectly fine. Like we're not going in and we're not like modifying the arrays. We're not like, I mean, I think this is still okay to say breaking encapsulation. I was about 50-50 of giving it a right answer. I just don't think it is the right answer here because none of this code actually breaks law of Demeter, right? And the important thing here is that the reason breaks encapsulation rather. The reason that this breaks law of Demeter is that we're going to grab the factory, and then inside that factory we're grabbing the warehouse, and then inside that warehouse we're grabbing a car, and then inside that car we're grabbing the wheels, and then we're grabbing the first wheel, and then grabbing the first wheel's material, and then we're going through and we're finding the wheel's friction index. And so if you think of it like, if you think of this as like an actual physical object, right? There's a lot of surface area, right? There's a lot of things that it touches. And so if any of these change, our code has to change. If any of these things break, our code breaks. And so it makes our code very fragile. We go and we change the name of this variable, suddenly now this has changed. Now maybe this is no longer an index. Now maybe this is like a percentage, or this is like some kind of like mathematical function, right? Now this entire thing has to change, right? And so what we're happening is that we're losing context, right? And we're not, and in some ways this is thus breaking encapsulation, but breaking encapsulation is more to do with the fact of hiding implementation details, right? And none of this is really necessarily implementation detail. In some ways, accessing friction index like this is kind of breaking encapsulation. It'd probably be better if it was at friction index. But I think in terms of how it works, I don't think it's enough to like really warrant that. Yeah. So hopefully that made sense. But the question, the answer is really law of Demeter, right? Because of the constant kind of accessing, and the main culprit is this thing here, and the fact that we're accessing the wheels, then accessing the materials, and then filtering out all the friction. The actual stream stuff here is fine. Like doing this is fine, doing this is fine, doing this is fine. The problem is this and like this, right? Um, and the thing here is that breaking law of Demeter is not always bad, because basically everything breaks law of Demeter, right? And that's kind of really important. Is every single getter in your program breaks law of Demeter, almost all of them. And so you can kind of see that with what we did last week, right? So if you look at the code that I wrote last week, right, which was the whole question bank, one of the things that you may notice is that most of my functions, they had very little ability to actually access the function. So like there was get name, but there was no get variations. There was no set variations. It was ask a question, randomly ask a question, right? And for variations, the same kind of thing. There's like some of them had some getters like this, and this is technically breaking, LOD, but it's okay, right? Because breaking a small amount of LOD is fine. And that's kind of the thing with this, that you don't always have to go extreme, and you should try to be as conservative sometimes with these like choices as possible. Like don't try to like go really crazy and try to like remove every getter, remove every setter, and try to make the entire design really complicated, right? Um, you got to balance things. But if you have setters and getters everywhere, then it can be a problem. Anyway, so you can kind of see the rough idea. You can look at this class if you want inspiration. This one's probably a better version of it, right? The idea that you can kind of hide most of the information away, so things don't really care about it. And so it makes the class very simple. And there's very little surface area. There's very little that can go wrong with questions like this, right? Because we're doing like streams in it, sure, but the streams are based on whether or not the variation is valid. We're not going inside the variation and like checking all the options and stuff like that. That would be bad. Okay, there's are there any more questions? Let's see. I think that was the last one. So sorry for being a bit weird this week. But hopefully that was at least a little fun, albeit maybe stressful. And next week when we do it, it'll be better because I mean there won't be next week, but the week after when we do it, it'll be better because I'll make the images larger and actually do things slightly better. So that's about 1.5 points, or 2 out of 5, as you can see here. So I mean it's pretty good, but I think people were pretty good for how quick it was. Anyway, these were pretty hard questions too, so don't worry too much. But hopefully that kind of helps you with understanding lower Demeter. Does anyone have any questions about that? Because that's kind of quite important for this week. Or any questions whatsoever. Like anything in the course material that you don't understand, you want me to explain again or whatever? Let's wait a minute or two. In the meantime, I'll get up the next example ready for us to modify it. We can close all those files and even will. Okay. Anyway, okay, so let's just go into the next question. Sorry for that one being a bit weird. So we have a few things here and we have to do these different processes, right? And so to begin with, for example, we have to find a yak within a list. And so this is a very C-like list, right? You're iterating through the list, then you're trying to find the yak by basically checking each one. And this is fine. It's just kind of very long. And so an easy way to write it is if you just want to find something, you can just go list. But then if my Java wants to cooperate today, which I probably do need to save this, so I was called like list dot. And I go dot here, right? One of the things I'll see is there's a bunch of methods, and one of the methods will be something called contains. Let me move this inside of, oh, there's actually this list right here. Oh, look at that, even better. So I'm just going to go to this example here, and we can just modify this. So if we want to find a yak, all we have to do is just access the lists. And so to access the list, we just can just say contains. So we're just going to try to see whether or not it contains yak. And if it contains a yak, then this will be true, right? Or in terms that will just return true. So we can do something like if this contains a yak, system out.println found a yak. Now the answer here is that we want to try to figure out what index this yak is at. So how do we do that? Well, there's this wonderful method here called index of. Right? And we can see index of returns -1 if there's no such index. And so basically it does an O objects that equals on every method up until this point. We can say, hey, give me the index of this yak here. And then we can say, hey, if index does not equal -1, add index at I. So the code's a bit shorter. Now, if we want to remove pig from the list, all we have to do is something like this. Remove pig. That's it, right? Rather than to go through and trying to remove the ith element, we can just remove pig directly. Now, how do I find this stuff out? Well, the answer is honestly I just do this and I just look for it. That's it. And I'll find it. Like I'll go look for remove and I'll find remove, and there it is. So remove all removes everything in a given collection, right? So remove all from this list of all of its elements are contained within this collection here. Oh, okay. We want to remove all? Well, there's another option for that. And let me just see what it is. Pretty sure. Well, let me see what remove does. So first off, we can look up what remove does. A remove may remove all of them by implicitly. You can see this. Removes the first occurrence. Okay, you're right. So it just removes the first occurrence. So how do you remove all? Well, one way you could do it is like this. Remove if. Remove if work. And we can give a predicate such as extra equals big. Right? And this, I believe, will remove all of them. Yep, removes all the elements that correspond to this predicate. So that's one way we could do it. What's we could do it? Well, another way we could do it is we could probably do something like this. I think with the remove all method, we give it a collection, but since it just checks if it's if it's listed in the collection, I think we can also give it pig and give it something like arrays dot as list. Right? And so what this is going to do is it's going to create an array of strings, right? As you can see here, list of strings. And it's going to have just a single argument called pig, and remove all will also work here, right? Because it's going to remove all the elements that's listed inside this list instead of just removing the first one. There may be another way as well, but those are the two ways that would also work. In this case, I believe pig just exists once, so this is fine. So if we look at this, you can see that pig just exists once. Okay. The next thing is printing out all the animals except for those that contain O's. Right. There's a few ways we can do this. Like again, the way you commonly do this is you could write, for example, some lambdas and stuff, but another way you could write it is just saying like this, a for loop. And so this is a special kind of for loop that maybe you guys aren't used to. I don't know how much they've gone through this one in lectures, but basically it's a special kind of for loop that's built around, I don't know, animal, sure. And it's a special kind of for loop that is what we call a range-based for loop. It may be called something else as well, but that's typically what's called in C++, which is why I remember it's range-based for loop. I believe it's called the same in Java, but maybe called something different. Doesn't really matter. And the range being from 0 to list, right? And so in this case, we're basically looping for every animal in the list rather than having to use I. So it makes the code shorter. And so we can say something like if animal dot contains O, then we can print out the scary message, else we can print out the happy message or whatever, right? Else. Right? And obviously instead of saying I, we can just give it animal. Okay, there's other ways we could do this too. For example, let's say we didn't want to print out anything if it's O's. If we didn't want to print out anything if it's O's, effectively what we're doing then is we're just going to be doing a filter, right? And we looked at this last week, right? And so we could do a thing called a stream, right? And so the streams are basically ways to apply an operation on every single element in the list. So in this case, it would be applying it something to every single animal in the list, and we want to apply it to irregardless of its position. So effectively, you can think of it as like a water stream that's going down. We have a bunch of like elements in that water, and we're filtering out the bad stuff. Maybe like increasing the pressure at certain points, decreasing it. Like we're able to do things on each molecule individually, but we're not really doing things overall. We're not saying, hey, if there's 10 molecules of fluoride in a row, remove them, else don't, right? Like we can't really do stuff like that. Well, we can, but it's much harder, right? It's not really meant for that. So in case like this, we could filter out like this, and we could say, hey, we're going to filter out as long as it doesn't contain O's. This contains O's equals false, for example. There's other ways to write that too. Oh, it's just literally the fact that I don't have a semicolon. Okay. And then at the very end, all we're going to do is just apply something to each operation, right? So map will work. There's also something called for each function, which allows us to apply something for each operation in the list. So in this case, if we want to print something out, we could just say for each this. Now it's probably going to complain because it's a function, so we have to do this, and then we're done, right? And again, when you choose which one, it's like really hard to tell, but typically if it's a function, you want to use this, right? But again, that's not always true. If it's based on like how it looks things up and whether or not it's a type or not. Anyway, you could also write it the other way, right? Where you write something like this and go extra print line X. Now, I don't know how much you guys know about this. I feel like I've explained it a few times. But again, when you do stuff like this or like this up here, you're defining a function that exists only within this, right? It's what we call an anonymous function or a lambda, right? And so what it's going to do is it's basically going to go and add a static function implicitly up here. It actually adds a class, but it's the same kind of idea. And in this case, this class is basically just equals pig. So it's just going to be a Boolean. We can call it like temp, whatever, right? Some random sequence because obviously we don't want them to collide. And it takes in what? Well, it takes in an animal, or which is a string, right? And so it's just going to go return animal equals. And so therefore, when we're applying this, we're literally just passing this function. If you've done function pointers in other languages, it's effectively the same kind of idea. The reason why it's complaining here is because what's happening here is this is not a local variable, it's part of the class. So again, have to access it like this. But yeah, same idea. I'll keep that there for the sake of it. Okay. So same thing here, we could filter them out and print each one out, right? Using this print primitive. And in other languages, you can go even further, right? So for example, in something like Haskell, right? This is one of the really nice things about Haskell. Let's say I wanted to write something Haskell. I don't have access to Haskell. Oh well. Let's say I wanted to do basically the same operation where I apply a filter. It's very easy for me to do this. I can basically just say, okay, print O's, or this is print non-O's, right? And this function, right, would take in a string and would also take in, or just a string, technically a string array. I don't remember the syntax of this or the other. I think it's this way. And it's just basically going to return another string array that contains just the O's, just the non-O's, right? And so to do something like this, it's very easy because I can do stuff like this. So I can go print non-O's, my original list. Well, this is a bit harder to kind of demonstrate, but I guess it's fine to do it this way. And so I could do something like this, where I got all my elements like X's, right? And I can just map them one by saying, I want to apply a filter to my X's, right? And the filter I'm going to apply is basically just going to be this. And so I can do what's called partial evaluation, where I'm going to say, okay, I want to grab contains, and I want contains pig like this. And so what I'm basically going to do here is I'm going to filter based on this list of strings, right? And verify they all contain pig. And one thing you notice here is that in this case here, we have to create this lambda to do this, right? Because we can't really like call a function with only like some of the arguments. When in a case like this, we didn't have to, right? We could just say contains pig. Though you would have to like do something a bit weird to get around the fact that the order here is different. So other languages like to express this a bit clearer, but in this case, it's fine. Okay. Now there's one last thing that we care about, and that last thing is this thing here, which is if the animal starts with an uppercase letter, we're going to swap it with the previous animal. So effectively, this yak will be swapped with the pig. Now, the reason I say this is contentious is because this is in the original too. Is that when you go I++, what's going to happen is it's not going to continually swap them, right? And so, for example, it will go through, it will go to cow, swap cow with goats, right? And so these two will swap. Then it will move on to pig, which means that cow just kind of remains the swapped position. So it's dependent on what you want to do. Like, do you want to swap it all the way down like a bubble sort, which is probably maybe what you want to do, or do you want to just like swap it in place once, which is kind of a bit odd, right? So typically, if you're going to be swapping stuff like this, where you check if it's uppercase, maybe you probably want like a bubble sort or some kind of order to it, right? Not just like swap these two for some reason and swap these two and then stop there, right? You'd probably want to like see it continually loop. And so if you remove this, it would loop, and you'd have to have your I++ here, right? Only increment when you haven't swapped. Right. And so the way you could write this would be just be using the for loop here. The for loop we had up here. Again, with this one here, you could also write the for loop that we had up here, as you can see here, right? These are both valid. And so we just iterate through this for loop, and for each one, we could just check this condition. Right. The problem here is that we need to be able to swap the arguments, and so we need increments for I, right? And so this prevents us from exactly using it like this. So maybe we could try to cheat our way through and have like an int I equals 0 or 1 here, I guess. I don't know why that starts at 1. Anyway, probably because they swap with the previous one, but who cares? Yeah, that makes sense because you're swapping with the previous one. You can't swap 0 with -1. Okay. And so we're swapping through all the animals like this, and we could add something like I++ at the end, right? And so what this would do is we're going to increment at the end of every loop, right? So the first one will be 1, then 2, then 3, then 4, then 5, then 6. And effectively, we're just rewriting this with more steps, right? And so in this case, there's various ways you can do this. but they're not very easy. And so in a case like this, just stay like this, right? Don't try to overcomplicate it. It's not particularly easy. If you care, the way you'd have to try to do it is because the indexes themselves matter, because of how you're swapping, you have two choices, right? The two choices that you have are basically either to try to reorder it when you're iterating through. So when you like create like a temporary copy of everything and you choose which one goes in which order based on the swap order. And so that would effectively give you the same behavior, right? And so you'd effectively order it based on that. Um, Again, if you would remove something like this and you were to make it loop over and over again until the entire list was effectively sorted, you could just do a sort, and then you could give a sort based upon the first uppercase character, right? And that would work. You don't have to get crazy. But there's not necessarily an easy way of writing this, but you could probably still do it if you really wanted to feel pain. Okay. I'm pretty happy with that. I think that's basically it. There's the UML demonstration. I'll probably just upload the video just to save time, unless people want me to do it in manual. If you want me to do a manual, just say. Um, all we'd do is we'd just create like a sample UML and just go through it. Anyway, otherwise we'll just stop here. Actually on time. Okay, so add all the elements and we can push it. And we'll update in a second too. Are there any other questions before we move on? Sure. Is there anything else we want to discuss? I'll just go for it. So law of Demeter is one of those weird ones. It's one of those ones that and actually Ethan could probably also add maybe a little opinion to this as well. It's one of those ones that especially in this course, right? This course is very opinionated. It proposes certain ways of approaching these problems, and so with with your own regards, right? You got to try balance your own opinions with the course's opinions and try to develop them as you go through the course, right? And so one of the things that the course talks about with law of Demeter, right, is the concept of trying to keep classes very simple and try to keep them single responsibility, right? And so, but not only that, you're trying to keep them encapsulated, and you're also trying to make it so that friends only talk rather friends don't talk to friends in depth, right? So the idea is that you don't just reach inside in another class and just extract everything, all the information that you want, right? And you don't just pull all out, like rip like the entire guts of the class out of the class out. I then just like try to look through it. Yes, that's a good idea, Ethan. Yes, that's correct. But the other thing to also point out is that OOP is not the only way to design software, and that software can be very maintainable and very, very, very good, regardless of whether or not you apply OOP. OOPs, yeah, within OOP. Yeah, exactly. Just want to point that out, right? And so the reason I say is because every year there's a few people who have kind of researched this before and who have opinions about it, very strong opinions, and they kind of hate OOP. We get them all the time. And so this course, regardless of what your opinions about it, you still have to do it. And you'll learn something. And OP is pretty good and it's very, very usable. But the whole point of law of Demeter, right, is trying to restrict access. And so I think the classical case is like getters are functions. The problem isn't to do with them being functions. The problem is to do with what you're doing with those functions. So for example, let's say, okay, let me give an example. So let's create a class. And what we're going to do inside this class is we're going to call this a car. A car is the easy example because the cars have a bunch of like stuff inside of them that we can easily extract. Or more importantly, let's call it a cake. Now, cakes are very dependent upon how you create them, right? So I can create a chocolate cake, I can create a mud cake, I can create a caramel cheesecake, I can create whatever I want, right? And so let's say we have a bunch of ingredients, right, inside of this cake. I can't say spell ingredients. I don't know why. Just looking at it made my brain feel weird. And these ingredients, right, consist of various different I guess in some ways it's like an interface, right? And so they each have like different properties to them, right? So some of them are like, for example, eggs are combiners, right? So they kind of like bond things together, like make things hold their shape. We have flour, which is like, for example, self-raising flour is like a riser. No, it means less. Wrappers in some ways. And so you have all these kind of ingredients that relate to each other, right? And so let's say I'm a hungry boy, right? And I really want some cake. And you give me a cake. Now, the problem with this, with like law of Demeter, would be if I went inside this cake and tried to access all of the ingredients and try to do things with those ingredients that are really hard to encapsulate and control. And so, let's say I have a public getter, and I actually follow some syntactical system, and I return my ingredients. Now, this seems fine, and it is in some ways, right? But the downside of something like this is that it allows me to just go and grab the ingredients and then modify it. I can, for example, add new ingredients. Like, and my new ingredient here, which could be like, for example, mud, like literal mud. Like this is not going to make the cake look nice or taste nice, right? Or for example, when I add an ingredient here, maybe it doesn't actually add it to the cake. Maybe like there's some internal metric, right? And so this is just like a tracking list that is what's in the cake, but isn't actually representative of the cake. I don't know. This implementation is hidden. This implementation can do anything. Like for example, maybe there's a database, right, which is like a big table that stores like a big just like a big like Excel sheet, kind of a spreadsheet, which stores like a bunch of information about this cake, right? And so when I modify this list here, it doesn't go back and modify the database, which means suddenly my modifications only apply while the application is running and don't persist. Right? I've just introduced a bug without knowing it. And the reason why is because I'm trying to interact with the implementation details of this class. And so in some ways, this is breaking encapsulation. This is like a specific point of law of Demeter, right? And law of Demeter is more generic than just that. Law of Demeter would be going even further in some ways. For example, accessing the first ingredient and then going inside that first ingredient and trying to like access properties about that ingredient, trying to change properties about that ingredient, right? And so instead of delegating responsibility to classes to own what they control, we're overriding that and we're basically manually controlling stuff, which means that the surface area of problems is increasing. It's much harder for me to predict how people are going to use my classes and how to design my classes so that they are bug proof than when I just expose everything and it's bedlam, right? And so a major point of LOD is trying to restrict the ability for bugs to occur by preventing people from, or trying to prevent yourself from going through and trying to excessively like add a little bit of like spice everywhere across the program, right? Um, and so you're trying to like control what stuff you access. And so, for example, let's say I wanted to add a new ingredient. Instead of having this ingredient list, why don't you just have a method called add ingredient, right? And then this can do things like go and write to the database and add it to the ingredient list at the very end. If you go, okay, but I actually want to be able to get the ingredients out to print them, right? Well, that's also okay. For example, you could return a read-only list, right? And that way you prevent modification. Or another way to be is that you could use the fact that toString exists, right? And so, for example, you say I want to get all the ingredients, I could have an override toString. And that would give me a representation of this cake. You also have, for example, get ingredients representation. And so the answer here is not to add a method for every single case that you need, right? You don't want to like over specialize. For example, let's say I wanted one for every ingredient that was odd and one for every ingredient that's even and one for every ingredient that matched the condition, and something gets really complicated. I'm having 20 different methods. Like you've gone too far, right? And the problem there is more that you're trying to get too much information about these ingredients, and that logic could be moved elsewhere, and so that you didn't need to have all these functions, right? And so the answer is if you're adding a bunch of extra functions to get around LOD, you probably have a design problem, right? Um, for example, if we have this get ingredients representation for odd, and we also have one for even, the problem here is probably that we could just have a single one with a bunch of options, right? That represent what options you want to, like for example, a predicate, kind of like a filter. That we say, hey, if you match this filter, include it in the list of ingredients that you're going to print out. Else don't include it. Or you could go even further. For example, some things would have like a builder pattern, right, which you learn later on, which allows you to construct maybe a query, right? And so, you could, for example, you could say like query ingredients. This would be a very extreme example, but maybe. Then it would be something like query dot where each ingredient matches a condition. And then you would apply this query on your object. So you're kind of abstracting away the concept of a list. Right? Again, in cases like this, it's probably just better just to return a read-only list, right? And sometimes it's okay just to return a list, right? It's okay to return a list because it's technically only LOD when people actually use that list incorrectly. So as long as you trust the people using your application, in some ways, I guess it's fine, right? In reality, we can't really trust people. But with your assignment and stuff like that, especially when you're beginning, don't worry too much about doing stuff like that. Worry more about breaking LOD in your code rather than trying to prevent it, if that makes sense. So rather than trying to like remove all getters and setters and do all this kind of craziness, that's good, and you should be trying to do that, right? But at the beginning, you can just try to prevent yourself from breaking LOD at the core site rather than trying to prevent it in the future, right? If they're very loosely coupled, does that mean more wrappers? As I said before, not really. And the reason why it's not really is because things that are loosely coupled basically aren't reliant on each other, right? And so typically things that are loosely coupled, there's two forms of coupling, I think, I would probably regard it as. The first form is bidirectional and directional, right? And so bidirectional coupling is when you have two classes which are very reliant on each other. That's kind of the worst scenario, right? Because what it means is that the classes are extremely reliant on each other's behavior, which means that it becomes very hard to change one of them because there's basically implications because the other changes, which therefore means that the first one also changes in response to that. And so you end up having to change a lot of code for simple changes because they're all very coupled and kind of like floating around in this kind of very very highly I guess in some ways highly cohesive, but very, very, very highly coupled, right? So instead, when you have loose coupling, you typically have less wrappers and stuff to access things, right? But it doesn't mean that you're accessing the things directly. It just means that you're abstracting your problem well enough that you don't have to know all the little things. Like that's the whole point of basically OOP is that you don't sweat the small stuff, right? You don't care about exactly how things are done. You only care about how the problem generally is solved. So, like when we looked at, for example, the question before, right? This was an abstract question, right? I don't care how this question is solved. All I care is the ability to ask the question, and then as an extension, the ability to randomly ask a question. Right? And currently, these are the only two methods I want. But let's say I want to ask a question that matches a predicate. Well, suddenly now we're running to like a lot of functions, right? But even then, maybe 3 functions is fine. But if I wanted to go along and do another thing, like at that point, okay, maybe we grab this kind of question logic and we let people know how many variations there are. We let people query the variations so they can figure out the predicate and then ask us for a specific question, right? But currently, right now, the only thing you can call is randomly asked question because this is protected, right? It's hidden within the package. So you people who want to use this question bank can't just directly ask a question; they can only randomly ask one. Um, and so this has less wrappers, right? We're adding less like layers. But yes, adding layers to things can reduce coupling. But it typically doesn't reduce coupling in a good way because it typically also reduces cohesion, which is bad, right? You want high cohesion. So if you're adding a bunch of layers in between two objects, the objects kind of become more abstract, and it's basically just a lot more code, and you're overcomplicating things. But you're also typically making the classes as cohesive to each other. They're like less. There's less. I guess there's a few ways you can think of cohesion, but like the basic idea is just like how well do they fit? So are there any ugly edges? Are there any hacks that you have to work around with them? Do they just like kind of work, if that makes sense? So for example, we have this cake here, right? And so this cake works pretty well for its ingredients. It's pretty highly cohesive, right? So for example, maybe there's a bunch of functions in the ingredients to determine how those ingredients function for other ingredients. Like for example, combine ingredient, right? Maybe that's a function that if you combine two ingredients together, you get a new ingredient back that like represents the like result of those ingredients. Like if I get eggs and water, oh, that's kind of weird. If I get eggs and flour and I combine them together, I get this kind of like doughy kind of floury mix. So then maybe I add some sugar and then some milk and then some butter. And as I combine each of these stages, I get slightly different ingredient combinations until finally I end up with some kind of cake mix that I can then combine with an oven or something, right? And so in that case, you could have high cohesion with the classes, and you're not really coupled to the classes because you don't really care about how it combines it, right? You don't really care how the combining works. You just care about the fact that it can combine it to produce a result. Like cake isn't going to go inside the ingredients. The class cake isn't going to go inside the ingredients and go, hey, are you this class? Are you that class? What's your molecular structure? What's this? What's that? So for example, if we had this method called like public void combine ingredient, right? And maybe we also have like, so this is like a kind of a tracking list, if that makes sense. This is like all the ingredients added ever, right? And then we'd also have like the current ingredient combination matches like the combination of ingredients. It would be kind of bad if we did stuff like this. If we go, okay, if the current get molecular structure, for example, like how, like, is this sugar, right? And what's the molecular structure of sugar? Then we like access properties about this and goes like interacts with the ingredients don't get molecular. Like why? Why? What's weird, right? Like if you look at this and you go, well, that's kind of weird because like, why do I care about molecular structure of this ingredient? Like what? Instead, like a better way of doing this would just be to say something like current equals current dot combine with ingredient. And so the difference here is that we're abstracting our behavior, right? And so we're reducing our coupling to the molecular structure. So we no longer are coupled to the molecular structure, and the classes work nicer together. Raphael and Jaden and other people also like Min and so on. Is that answering your questions? It's hard. It's not easy stuff, right? So like you'll write classes that are terrible and you'll write classes that are good. And it's really hard to tell which classes are good and which classes are bad for a very long time. And even when you've been doing it for a very long time. Yeah, honestly, the hint I can give is the only way you'll ever write good code is to write bad code. Like, not even kidding. Just write like the most terrible code you can think of, and then look at the code and don't go shopping for fixes. Like, you don't want to go, okay, what fixes can I apply here? You want to first identify what the problems is and then identify the best fix for that problem. You don't want to just go, okay, oh, I found this cool new algorithm I can use. I'm just going to apply it. Like, oh, I found this cool new OOP thing. I'm just going to apply it, right? Else, what happens is you're just going to increase the complexity of your solution without necessarily making it simpler. So, for example, a very bad solution may have stuff like this. And so the fix is not to go around and go, well, where can I apply LOD? The fix is to go around and go, okay, where specifically is there a problem? Where do I have too much coupling? Oh, I've got too much coupling here. How do I fix this high coupling? Oh, in this case, the way I can fix this high coupling is by doing XYZ. And so typically, I would say some of the best OOP code. Yes, that's a good idea, Ethan. High level issues. And so high level issues. I mean, you could give a good example. I've got one or two. But I would say if we can remove applying over the hand. Yeah, it's very hard. I was like when I'm talking about stuff, I'm having to come up with examples on the spot. I mean, I've got a lot of work examples, but I got to think of examples that aren't like private and I can't like I'm able to share. But like typically, the least code you write, the better. So if I can remove code, that's amazing. Like programmers should not be writing code; they should be removing code. And so I always try to say, like, my aim whenever I'm writing code for like the company I work for, right, is I want to remove about 30 to 40% of the lines I add, if that makes sense. So let's say I'm making this big change and I'm adding like 200 lines. I want to try to remove like 50. And the idea is like 50 on top, right? So that means that basically I am ending up with a net positive of 150 lines. The idea is that you're trying to restrict how much the code is growing by, but you're also making the code refactored and simpler and shrunk. And so a classic example recently was we have this system at work where basically it's like a send system that we run. And so we give it like a configuration that's quite complicated. Um, Let me get up an example of configuration. So the question could be like, hey, go load this Excel file, and then process this Excel file and load it into a special table, right? Like a database. And then from that table, filter out all the records that match a certain condition. And then from that condition, send a bunch of push notifications to all these iOS devices, and then also send a bunch of emails to these people. And then also generate reminders for these emails and all these other things, right? Um, and one of the changes, so let me do two things. Let me first grab a config and what's a decent config? Oh, this will be fine. And so for example, config that doesn't have anything secured in. Load will be fine. Positive load. Nope, that's not got anything in it. Oh, sure, this will be fine. So for example, if I grab this record here, I'll move it across in a second. Here we go. And so if I grab this very reasonably large load of send here, what it's going to do is load a bunch of stores from a CSV file, does a bunch of like SQL schema junk on this. We don't really have to care about this. And then the next thing it does is it goes through, loads another CSV file for some extra data. This is like a reference data up here. And then this is like the actual trigger data that we're sending records on. It loads a bunch of transactions, creates like a SMS and an email fields, and it does all this other stuff, right? And then this is like logic. Okay, the gender has to be female. You have to be greater than 45, and you have to be from this store. and then it decides and does all these populated dispatches and queues, right? And so one of the changes I made recently was to abstract one of the modules, something called load from pool, which basically was like a table that always existed and that you could like say, okay, I only want to send out 20% every day, right? And so the first day I would send out, let's say 10, and the second day I would send 10 again, right? And so records kind of stay in the table and get cycled out over time. And so we wanted to abstract that into a more simpler concept that wasn't staggered. So basically, it would just pick up everything. And so one of the most amazing things from this is that basically the module in the very end is this big. So we went from being like 400, 500 lines to being like 3. And in reality, it didn't even need to be this big. This was actually like, if we didn't write this the opposite way around, normally you want to write higher up than low down. So you want to write like the simpler, the like super classes than the base classes. In this case, we wrote base than super just because like, it's a business, right? So the way you write code in a business is typically different than how you would always like. And so in that regard, we had to kind of keep this class around. But in reality, this class does not need to exist. And like a lot of this stuff does not need to exist. But there are some unique templates for this, like unique SQL queries and stuff that this class generates. But if we look at this main module, this includes all the logic that could be extracted, right, and simplified, and it all gets in here. And so it's pretty cool and stuff. And this is a very, very large freaking module, and it's only one of many. And so maybe I'll show some more examples of stuff like that in the future. But typically, you want to try to restrict the problem space down to as much small as possible, right? And try to like prevent things from talking to each other too much, and try like basically, I don't know. You kind of want to create like a. Okay, I'm not going to give that. I'm going to try to keep myself politically somewhat correct. So, like, let's not go. But there is like an example relating like world governments, right, and trying to keep, relating world governments to this kind of problem here, right? But yes, you want to like give every class its own unique responsibility, prevent it from talking to other classes, and trying to like, if you can do that, then you can kind of like seize the means of OOP, right, and actually be able to like get higher productivity from it, because you end up with less coupling between states, and it's much easier to make refactoring changes and so on. Anyway, the only other thing I would say is that when you're writing code, especially for this assignment, write code that's easy to refactor. So like the typical thing people say to you is like, what is it? It's like hard to modify, easy to extend, I think. The final extension to that is this: make it really easy to refactor, right? So I should be able to like grab your code and completely like refactor most of it to like add new behavior or whatever as needed, without having to like change a bunch of other classes. Like it shouldn't have high coupling. So if you can't just like go through and refactor all your code without it being too easily, like for example, when I refactored that pool module I'd mentioned before, one of the best things is that instead of referring to it as pool, in a lot of places they had this generic referring to it. They referred to it based on the table name, which is always pool because it's a pool table. But